And welcome, Lori and Michael and Dawson and Heather and all of you that are watching this archived. And so welcome all of you. The plan today, I'm going to share my desktop first and then I'll unshare and answer some questions. So the plan today is kind of a graphing day and understanding graphs too. But in particular, we're going to start out with plotting points, and then we'll get into plotting lines. And then we'll plot the estimate of a regression line. So I'll talk what that means. And then we'll talk about interpreting the equation of the line. That'll be the hardest part of this week, actually, is how do you interpret the slope and the y-intercept of a line, because that involves language. And then after that, we'll get into solving linear equations. So the good news is, unlike last week, this week is not all word problems. We actually have some non-word problem stuff to do. So now that's the plan, and I'm going to stop the share because I know that we have someone who wants to share. So are there any questions? Hint, hint.
Yes, my question is, how do you do number 7 on the summation notation? Can I share my screen?
Yeah, that's the best thing, is to share your screen.
Okay.
And we'll take a look.
There it is.
Okay. So again, the formula is quite intense, but that is the formula for what's called the chi-squared test statistic. And it's given by the summation I equals 1 to n of OI minus EI squared over EI, where OI are the observed values and EI are the expected values. Use the following observed and expected values to calculate the chi-squared statistic, and then round 2 decimal places.
We're just plotting in the numbers there.
Yeah, so what you're gonna have to do, so first thing, let's understand what this formula means. So first, what is that big capital E looking thing called sigma? What does that mean?
Sum.
Yeah, that means add them up. Okay, and it says I equals 1, so that means we start at the first one up to n. So in this case, what's n?
It's unknown, right?
No, we know it. In this case, for this example.
Oh, okay. It's 6.
Yeah, it's 6. So it means there's going to be 6 things to add up. Does that make sense?
Yes.
And each thing is going to be found by taking the O, subtracting the E, squaring it, and then dividing. Is that clear?
So we do each one individually, and I guess what's confusing to me is that this like table is there. So
you need the table. If you don't have the table, we can't do this.
Yeah, so we plot each one in and square it individually.
Yeah, so let's start with the first one. So let's do an example. So we're going to take O is 5 for I equals 1. Do you see that?
Okay.
E is 11. And for order of operations, you have to do the inside the parenthesis first. So we do 5 minus 11. Is that clear?
Yeah.
Now 5 minus 11 is negative 6. Is that clear?
Yes.
And then negative 6 squared, because again, you do the square next, is 36.
Okay.
And then 36 over 11 is not so pretty. It's 3 point, I don't know, 1 or 2 or something like that. But let's just think about it as 36 over 11. Does that make sense? So maybe in the answer box, just for now, put 36 over 11.
Okay.
Just so that we can communicate and everyone can understand. Okay, then we're going to go plus. So go plus, because we're doing a sum. And now let's do the next one. The next one will be a little easier. And that's going to be 6 minus 7, right? Is that clear?
Yes.
Is negative 1. Negative 1 squared is 1. And then divided by the E, so it's 1/7. So it's plus 1/7.
Okay.
Okay, and then you keep going. Is it okay if we don't do all of it?
Yeah, that's fine. I was just wondering if we did the subtraction and then squared that big number. It was really hard. I worked on that a little bit each day and couldn't figure it out. And I think seeing the table and the OI and the EI is new on this, so it's confusing. But
yeah, but the way we try to do this is try to make the questions relevant to what you're going to have to see in the statistics class. And that's what the formula looks like in stats.
Okay, and then so maybe I can private message you just because this one was a little confusing for me because oh no, I think I figured that out. I forgot to do the square root every time and I
If you forget it, it'll tell you wrong every time.
yeah. Okay, so I seen that I was like, oh God, the square root's there. That's why I keep getting it wrong. So thank you. But then that's the same thing, right? You plot in those numbers. X with the line over it is the 10.125.
We call that X bar, by the way. That's very important because that's a biggie in statistics. So just remember X bar.
X bar and Y with a hat. Okay. I think we're good. I'm just a little, I'll have to practice some of these because if any of the number 6 or 7 is on the final, I'm not going to get it right without practice.
Right. And just let you know, they're totally randomized. So I don't even know if it's on your final. Everyone's final is different, whichever the computer decides. So cross your fingers, but even better is learn how to do it.
All right. Thank you.
Okay. Great, great. And again, the whole point of these webinars is to have this conversation type of stuff. Otherwise, I just make a video and have you watch it. But it's much better if we can talk to each other and, you know, and interact so that you can have your questions answered right away. Are there any other questions before I get into graphing? Any other questions? Okay, if they're not, I'm going to share my desktop and then we're going to start working out things. This is going to be a lot different than last week because last week it was all word problems. So it wasn't like there were ideas to share. It was just doing examples. Whereas here, there's the ideas and you've all seen these ideas. I know that, but it doesn't mean you remember them all. So I kind of pretend that you forgot everything. So I apologize in advance if you did remember and I'm still going over it. Okay, so the first thing I want to talk about is plotting points. And when you plot points, and I'm going to do it by hand first, and I'm going to kind of show you prettier ways of doing it. When you plot points, the first thing is we have something called the XY plane. So in statistics, in elementary statistics, you never go past 2 dimensions. I know we live in a 3-dimensional world, but it's very hard to do 3 dimensions. So what you do is you only do things in 2 dimensions. And in particular, in the statistics that really uses this is called regression analysis. And I'm not gonna go over all the details of it, but I promise you that regression analysis is very important, okay? And there's a whole week on regression analysis. So what regression analysis is all about is you have 2 variables and we plot the points. So I'm going to do an example. I figure I might as well do something kind of fun with you. I do this in my stats class too a lot. Let's plot some points and hopefully we get a variety of answers. And there's a good number of you that it won't take too long, hopefully. And what I want you to do, I want you to answer 2 questions. And I want you to answer them in the following way, okay? And I'll do mine. I'm not going to plot mine because I'm older and done a whole lot of college. But the first question is, how many years of college have you had? And the second question is, how many jobs have you had? Okay, so what I want to do, I'm using this as an example because it's something we can relate to. And by the way, if you don't remember, just guess, it's okay. We're not, you're not getting graded on this or anything. If you look at my years of college, total number of years I've been in college while I was taking classes, it's 12. Okay. I've had a lot of college, by the way. And I don't mean teaching college, I mean taking classes. And then how many jobs have I had? 27. So the first thing I want to mention is when you describe points, this is the notation that you use to describe points, where we have two coordinates. The first coordinate we often call the x-coordinate, and the second coordinate we often call the y-coordinate. One of the main reasons why you call it x as the main variable is that there are very few words in the English language that start with x, so there's very little confusion if you just call it x. In fact, I've never seen a real math problem where it was counting how many xylophones you have, or x-rays or something like that. X is very, unusual for a word. So note that in general, we call this x comma y. Any questions on that? Okay, so that's the first thing, is that's how you read a point. Now I'm gonna have you guys do it, and then we're gonna do some plotting. And I'm gonna hope that your numbers are probably smaller than mine, and that's okay, you don't feel weird. I'm a professor, so that's what I do. I do college, and I'm also old, so I've done a lot of jobs. Okay, so see if you can put in the chat box. I want to see the answers to your questions as an XY coordinate. And let's see if you can do it. And I'm going to type it out. And again, because this is confidential, I'm not going to say who said what. 9,6. And then we have 8,11. Then 2,8. Don't forget to put parentheses around your point. And then 7,4. 1,8. 4,13. I didn't expect you guys all to have had so much college. These are years. I mean, if you have 9 years of college, that could be a PhD right there. Maybe we have some doctors. Okay, so that's the first thing. Now what I want to do is I want to plot those points. I want to write it down on paper because I'm going to lose the space. 8,11 and 2,8, and then 7,4, 1,8, and 4,13. So to do that, I am going to do a little drawing. And first, I'm just going to do it kind of by hand way of doing it. The first thing you do is you draw what we call the axes. Any questions on drawing the axes? Okay, and in fact, I'm going to draw this one. Why am I drawing it kind of way down and only to the right? Any thoughts? Yeah, there's no negative answers. And when you're creating graphs for statistics, you want to look at the numbers and use the numbers, use the points to decide on how you want to do things like, do you want to center the axes or do you want to place it so that almost all of it are the positive stuff? And in this case, everything's positive, so there's no reason to have anything really on the negative values. Any questions so far? The next thing we do is we're going to label the axes. So let's label the axes. And the first question was college. And the second question, so the second label, was work or jobs. Any questions on that? So it's always a good idea to label. Again, generally it's X and Y, but in statistics, they always mean something, so you want to write down what they mean. Okay, the next thing we have to do is decide on the tick marks. And in this case, what I'm going to do, I'm going to use yours, I'm not using mine, because again, I'm an outlier is what we call it. So what we're going to do is we are going to look to see what are the numbers like. Well, in this case, the highest number for college was 9. So what I need to do is I need to make sure that I can fit in up to 9. So by the way, if the highest number was 900 for something, don't count by ones. Just like we did on the XY, on just a number line, same thing with the XY axes, is you decide on the tick marks, and let's pop in some tick marks. So we have to go up to 9. So 1, 2, 3, and again, I'm doing it by computer. It's hard to make it perfect. 4, 5, 6, 7, 8, and 9. Any questions on that? Let's label them. So 1, 2, 3, 4, 5, 6, 7, 8, and 9. Then we do the same thing for the jobs axis, the y-axis. But now for the y-axis, we have to go up to 13. So I'm going to count by 2s, because 13 is a lot of tick marks. So that's 2, 4, 6, 8, 10, 12, and 14. Okay, and I'm not going to put all the numbers in because I don't want to waste your time, but you definitely want to put the first number in, which is the 2. And then we can count in our heads. Any questions on that? Okay, so now what we're going to do is plot our points. So to plot the points, you just stick a bunch of circles in. So we have 9, 6, which is about right there. Any questions on that? Let's make it red. I think it'll do. Okay, and then the next point. Was 8, 11. So that's 2, 4, 6, 8, 10, 12. It's way up here. And then the next one was 2, 8. So 2, 2, 4, 6, 8. That's about here. And then the next one was 7, 4. So 7, 4. And then the next one is 1, 8. So 1, 2, 4, 6, 8. And then the final one's 4, 13. So that's 4, and way up here. And there we go. And now I plotted the points. Again, this isn't, perfect because I just used Google Sketch. But that's how you do it. Any questions? Any questions on that? By the way, just interesting, do you see any pattern? Does it look like if you knew how many years of college someone had, you'd have a really good idea of how many jobs they've had. Take a look. What do you think? Less jobs, more college? Honestly, I don't think so. I don't think there's any pattern. It's all over the place. There's some lots of college, not so many jobs, lots of college, lots of jobs. Then there's not much college, middle amount of jobs. So you're going to learn in statistics, we're going to say that there's no correlation between the two. Okay, and I had no idea actually whether there was or not when I started asking you, at least for this group. But these are all over the place. So there isn't a clear line. Sometimes there is, and then you have to know how to do it. Any questions on this example? Any questions? Okay, so that's the idea of the XY plane. In this case, it's the college jobs plane, and how to plot points. Was this a good review, or did I waste your time? Okay, so we plotted points. We want to be able to plot lines also. Okay, so plotting lines is important. So to plot lines, let's suppose we have the line y is equal to, how about 2x plus 1. I'm going to plot that line. And let's even plot it on the same so I don't have to redraw the whole thing. So y equals 2x plus 1 I want to plot. So we want to look at that. And let's, I think I can edit it. There we go. Hopefully it lets me. Good. And we want to plot the line y equals 2x plus 1. So first thing, maybe I'll even put this in here. Y equals 2x plus 1. Actually, let's bring it in. Do you remember, I know it's been a long time for most of you, when you see that 1, what does it tell you? And you remember, when you have an equation of a line, y equals 2x plus 1, again, this might have happened in like 8th grade or 9th grade and you haven't looked at it since, so I understand if you don't remember. Slope, good guess, but not quite slope. Starts at 1, I like that. But in particular, it crosses the y-axis at 1. So it crosses the y-axis at 1. So we know that. I'm just gonna plot that point just so that I can mark it. So it crosses the y-axis at 1. Let's give it a fill. Any questions on that? Okay, what about the 2 in front of the x? What does that tell you? The hint is, Lori might have an idea. That's a hint. That's the slope, exactly. So the 2 is a slope. And what that means is that if we go over to the right 1, that means we go up 2. So if we start at 0, 1, we go over to the right 1 and up 2, then that tells us that we're going to end up at 1, 3. So let's draw that point 1, 3. Because what I did is I moved over 1 and I moved up 2. And when I do that, I end up at 1, 3. Anyone lost on what I just did? Okay, so I want to draw 2 points, and then one of my favorite games when I was 3 years old, when I have 2 points and I want to draw a line, what do? What's the game called? For children, mostly? Yeah, connect the dots. So let's connect the dots. So what I'm going to do is I'm going to draw a line, and it's going to connect the dots. And there we go. Okay, maybe I'll make it red, just for fun. Any questions on drawing a line if we're given the equation? Okay, so we now know how to draw points, and we know how to draw a line. Okay, very mathy. Let me show you the nice, easy way of doing it. That's with the computer. And here's Desmos, for example. There's a lot of programs that do it. I can just do y equals 2x plus 1. So 2x plus 1. Y'all agree that was really easy? Okay. You could also draw a point. How about 2, 8? And there's the point. Any questions on that? Okay, I'm a much better artist when I have a computer program to use. Yeah, there's a website, DESMOS. They're actually out of San Francisco. I met the founders. Actually, one little piece I built. Just a little one. I just sent them some code and said, why don't you do this? About a bunch of years ago. But this is the #1 website for graphing, for 2-dimensional graphing. That's what most people use. Okay, and it's really easy. That's the nice thing. Now, on your homework, you're going to have a built-in system into your homework. But it's the same idea. Click point and you click it. Okay, it's a little easier than this, actually. Any questions on seeing it on a computer? Okay, let me do the following. I'm going to get rid of the 2x plus 1. I'm even going to get rid of, I'll keep it 2, 8. I'm going to draw a bunch of points just for fun. Let's say we have 2, 8. Let's say we have 5, 1. Oh, can you hear me still? I'm a little worried. Everyone okay? Good. Let me tell you a disaster that happened this morning. I gave my calculus lecture, and fortunately we were almost done, and my internet died. And that was the end. Lecture's over. So if all of a sudden I stop talking and I go away, then it's not because I was mad, it's internet issues here. It's the problem with working from home instead of the college. And I'm not allowed in the college. So sorry about that. Let's cross our fingers that we don't have that problem today. Okay, so let me draw some more points just for fun. How about 3, 6? Okay, how about 3, 4? Okay, how about 4, 5? And maybe I'll do one more. How about 4, 6? Okay, so by the way, do these points all lie on a line? Do they? Yeah, they definitely don't. Okay, you can try all you want. You're never going to get a line that goes through every point. Okay, if there's 2 points, it always works. When you got a bunch, and they're a bunch from real life, you're not going to get a line. But here's the next question. Can you visualize a line that's kind of close to the points? What do you think? Okay, the hope is you should be able to. Okay, so when there's a line that you can visualize that's kind of close to the points, then we say the points that we say that the x and y variables have a correlation. You probably heard those words before, and that's a statistics word, that they're correlated. Okay, in this case we have a negative correlation. Hopefully you can visualize it, and when you visualize it, you see a negative slope. Do you all see a negative slope? It goes down as you go from left to right. Hopefully you're all visualizing the same line. Okay, now that line is called the regression line. And what you want to do is you want to say, well, what might that regression line be? Now, we do not have the sophistication as a class to be able to come up with a line, exactly. But you could probably draw a line. Okay, you can probably draw a line and see it. Okay, you could visualize it. Now, I don't think you can draw it because I don't think you're allowed to draw on my screen. But I can draw it, and I can see if I draw that, it looks like the y-intercept's around 10, doesn't it? Any questions on that? Looks like the y-intercept's around 10. And then if I draw that line, it's going to go down like that, somewhere around there. So if you go down 10, looks like you're going to go over maybe 7. Okay. So that's the rise over the run. So the rise is -10, the run is 7. Any questions on that? Which is about -1 point. So 1/7 is about 0.1428, or how about -1.14. So the equation of the line is going to be y is equal to -1.14 x plus 10. Okay, maybe the slope is a little bit steeper. Could even play around with it. Maybe about there. Did you visualize a line that kind of looks like that? Okay. So again, you're going to be asked to just draw it, but since I can't make it fully interactive with all of you drawing on my screen, I just have to explain how to do it. Any questions on this idea? Okay, so now let's go back. And let's talk about what we've done. And now comes, let me save and close, okay? So we now understand how to plot points. We understand how to plot lines. And we understand maybe how to plot the estimate of the regression line. Okay? Any questions on that? Okay, now it's time to understand the line. Question? Question? Okay, so now it's understanding the line. And I'm going to do it by example. And as I mentioned, this is the hard part. Okay, my guess, maybe I'm wrong, but my guess is that most of you followed me plotting points and graphing a line and visualizing the regression line. But the understanding is harder because that's words. So let's suppose that the equation of the regression line that relates number of years of college a college student has had to the number of jobs they've had is, and let's say it is y hat. Let me make it pretty. There we go. There we go. So it's y hat equals, and let's say it is 2x plus 4. So the question is, interpret the slope and interpret the y-intercept if it has meaning. Okay. Any questions on the question? Okay, let's start out with the slope. First thing, what is the slope of this line? If a few of you can chime in, see if we have agreement or not. Good, good. Okay, the slope is 2. I want to give you a warning. This is a big warning. When you think of the equation of a line in general, what do you usually write? Y equals what? You've heard this before. So what are the letters you use for the equation of a line? Yeah. Okay, now let me give you a warning. So caution. Don't call it mx plus b. Okay. I know this is the last thing that you would expect me to say because that's how you learned it, right? Okay. But don't do that. And the reason is in statistics, they typically use a plus bx and b is the slope, just to confuse you. Just kidding. But they do use the a plus bx. The reason is too advanced for me to explain. So what I'm going to do is I'm just going to use the word slope. And then I'm going to use the word y-intercept. I'm not going to use the letters m and b because that will zap you in the stats class. So it's better to use the words than to use letters because b is the opposite in statistics. Sorry about that, but don't blame me. I'm not the one that decides these things, but there is a reason. Okay, so the slope is 2. How do we interpret this number 2 in terms of years of college? Should be years of college and jobs. And that's the hard part. So the first thing I recommend doing is make sure the slope is a fraction, or write slope as a fraction. In this case, the fraction. Now, whenever you have our slope is 2, it doesn't look like a fraction, but there's a trick that you can always use to make a number a fraction. And what is that trick? Who remembers? Yeah, I put it over 1. Not 4, but 2 over 1. Slope is 2, so the fraction is 2 over 1. Okay, so let me make a fraction by putting it over a 1. Any questions at all on that little trick? Any questions? Okay, I should write for the slope for step 1 and 2. Step 2, right? Rise or run. Maybe I'll even, yeah, it's fine, overrun. Okay. So nothing to do there. Just remember, slope is rise over run. Step 3. The rise is the change in y. So interpret what a change in y means. Okay, so in this case, what does y represent? In words. So in this example, what does y represent? Yeah, y is not the number of college. Yeah, it's the number of jobs. Okay. Okay, so the y is the number of jobs and the x is the number of college. So what we can say is that the rise represents the change in the number of jobs. Step 3. Step 4, sorry. Similar is the run represents the change in x. And remember, we're always putting it over 1. So interpret what a change in x by 1 means. So in this case, what is it? What's a change in x by 1 for this example? Yeah, but as in particular, it's 1 more year of college or an additional year of college. Isn't that what a change in x by 1 means? And then finally, step 5, put 3 and 4 together. So what that means in this case is that for each additional year of college, we can predict that a person will have had an additional 2 jobs. Any questions on that? Any questions? So I want to warn you, watching me do it is not the same thing as you doing it. And it's one of the reasons why I've really made the step-by-step, because when I taught this last quarter, this was the hardest thing for everybody. is to try and like make words out of this. So you want to practice. Okay. And I want to let you know, because the computer system doesn't like read your sentence and know whether it's successful or not, it's going to be multiple choice. But try not to treat it as multiple choice. Try to write it down and then look before you. So don't look until you write it down. Because when you take statistics, you're going to have to write it down. So it's a good skill to learn, is how do you write this kind of stuff down? Okay, so that's interpreting the slope. I'm going to put above it so we can actually see the line at the same time. Let's interpret the y-intercept. I'm not sure how this slope 2 came over here. I didn't put it there. I think it automatically did something. Is that there? Oh, I know what it was. No, that was fine, actually. It was slope 2, not step 2. Sorry about that. So let's interpret the y-intercept if it has meaning. Okay, so the first thing, what is the y-intercept in this case? Looking for a number? Yeah, it's 4, and then I'll write what you wrote in a bit, but I want to make that step 1. So step 1 is write the y-intercept as 0, comma, y-intercept. Notice I'm not using a letter because that could be a disaster, because you're going to want to write the y-intercept as b, but that doesn't work when it comes to the using statistics. So I'm going to write y-intercept. You can write int if you want. Okay, so in our case, it's 0, comma 4. Any question on step 1? Step 2. So now that we've written the y-intercept, now what we want to do is interpret what it means for x to be equal to 2. I mean, equal to 0. So what does it mean? What does it mean for x to be equal to 0 in words for this example? Okay, it's directly in the y-axis, that's true, but that's not going to help at all. We need to see what it means in terms of the sentence. Let me read this again. Suppose the equation of the regression line that relates the number of years of college a college student has had and the number of jobs they've had. Yeah, so it's true that it hits the y-axis, but that's not going to help us. Better is no college. Okay. So they're just starting out, right? They haven't had even a year of college yet. Okay. Step 3. Interpret what it means for the y value to be that y-intercept. Okay, so our y value here is 4. What does it mean for y to be equal to 4? Yeah, they've had 4 jobs. So in this case, the person had 4 jobs. Step 4. Is if either step 2 or step 3 are meaningless. Then quit. Okay, so in this case, is it meaningful for someone to have not had college yet? Had 0 years so far of college? Is that possible? What do you think? Yeah. Is it possible that someone could have had 4 jobs? What do you think? Yeah. Okay. Yeah, someone could have had 4 jobs in their life. There was a point in my life I had 4 jobs. In fact, in all of your lives too. And in fact, one person has had 4 jobs. Okay. Let me give you an example where it would be meaningless. Let's suppose we had y hat instead of 2x plus 4. Let's suppose we had 3x minus 1. Then the y-intercept is -1. Why is that meaningless? So what do you think? Why would that be meaningless? Yeah, you can't have negative jobs. It doesn't even have, it can't happen. Does that make sense? So that would be meaningless. Okay, in this case, I gave you an example that did have meaning. So step 5. And step 5 is put together step 2 and 3. Okay. Notice if step 4 had no had no meaning, don't even go to step 5. Makes no sense to put them together. All right, so in this case, no college, person has 4 jobs. So we'd say the best prediction for a person who has not had any college yet is that they have had 4 jobs. Any questions on that idea? Doesn't like my grammar, but I think it's right. Oh, for the A. No, they were right. Any questions? Okay, do you see why this is difficult? Okay. It's not difficult to watch me do it, but you have to be able to write words. Okay, and that's why I did a step by step by step by step process, because I didn't last quarter. It was a disaster, actually. Almost no one knew how to do it. I'm hoping this works. It may not, but I'm trying this way. Okay, any questions at all on the y-intercept or the slope, and how do you interpret them if they can be interpreted? Any questions on that? Okay, the final thing to talk about today is how do you solve linear equations? Okay, and that won't be nearly as hard as interpreting the equation of a line, but it's something you have to do, so we need to. So let's go solving linear equations. Okay, so let me give you an example. So suppose, actually not, that a z-score was found to be, And I'm going to write the general equation, and then I'll talk about some numbers. Z equals x minus mu over sigma. Make that bigger. Okay, so that's the equation for a z-score. If the mean mu for the number let's say, how about for the weight of a cat is 4.5 pounds. By the way, I have no idea what it really is, but I'm making up some stuff. And the standard deviation is, gosh, the standard deviation sigma is 1.3 pounds. And a cat is considered an outlier if it weighs, if its z-score is at least 2. What is the weight of a cat? Actually, what is the minimal weight of a cat that is an outlier? Any questions on the question? Okay, so what's the first thing we do? Any ideas? Okay, if you don't know, first thing you do is plug in all the numbers that are given. So what we can do, we have the z equals x minus u over sigma, and I think I'm just going to copy it and paste it to show you that what I'm doing is I'm plugging in. The z, do we know the value of z? Yeah, the value of z is 2. Okay. Do we know the value of x? Yeah, that we don't know. That's what we're trying to find. Do we know the value of mu? Yeah, that's 4.5 because we're plugging in. Do we know the value of sigma? 1.3. So that's the first step, is plug in all the numbers that you're given. Now what we're going to do is we need to solve for x. All right, so what's the first step to solve for x here? Okay, 1.3. Yeah, we're going to multiply both sides by 1.3. And the way you remember is you're doing the order of operations backwards. Because first you subtract because it's above the division line, and then you divide. So now to undivide, you multiply. So what we can say is that 2 times 1.3 is equal to x minus 4.5. Okay, what's the next step? What's the next step you have to do? To get x by itself? Yeah, we add 4.5. So we can say is x is equal to 2 times 1.3 plus 4.5. And you're allowed a calculator, so I'm going to pop it in. Oops. There we go. And I get 7.1. And that's the outlier weight. Any questions on this example? Okay, so again, when you're solving linear equations, the first thing you do is plug in all the numbers you know, and then you undo order of operations backwards to get x by itself, and then answer the question. So it is a little past 7, so it's just about the right time. And the secret word? The secret word of the day is label, because you want to label your axes. Okay, when you're drawing the XY axes, you want to label what they're called. Okay, so that's what I've got for today. Let me unrecord.